We all know the story. Tony Stark, trapped in a cave, builds a glowing electromagnet in his chest to stop shrapnel from piercing his heart. If we apply real-world physics, this exact setup guarantees immediate death. A standard electromagnet creates a strong unidirectional pull. Instead of holding the Jericho missile shards in place, it aggressively drags those jagged metallic pieces forward toward the anterior chest wall. Pulling sharp metal through highly vascularized lung tissue and the pericardium causes catastrophic internal lacerations, leading to severe hemorrhaging and immediate death, long before the first armor is even built. Swapping out the electromagnet for a high-powered permanent magnet fails chemically. Permanent magnets degrade rapidly when subjected to the repeated physical shocks, high humidity, and elevated core temperatures inside the human chest cavity. The device holding Stark together operates as a complex biomechanical suspension system, utilizing localized electromagnetic fields to achieve a state of internal biological stasis. Tony Stark's first true superpower was the real-time engineering required to guarantee his own biological survival. To maintain biological equilibrium, the miniaturized arc reactor generates an active, multidirectional containment field. This localized zone of magnetic suspension neutralizes kinetic forces, holding the microscopic fragments in fixed suspension and preventing them from migrating deeper into the heart muscle. The extreme biological stakes of this system become obvious when the field collapses instantly, as seen when Obadiah Stane forcibly extracts the unit. The sudden absence of magnetic suspension leaves the loose shrapnel vulnerable to natural blood pressure, respiratory movement, and gravitational pull. These forces rapidly carry the mal into the right atrium, triggering acute cardiac arrest in roughly 15 minutes. Observers often ask why Stark refused standard thoracic surgery to remove the metal upon returning to the United States. The reality is that medical technology in 2008 was inadequate to address his condition. The shrapnel fragments were microscopic and highly dispersed throughout his thoracic cavity, rendering standard CT scans and X-ray imaging useless for precise surgical navigation. Using a magnetic resonance imaging, or MRI machine, to map the fragments was completely impossible. The intense magnetic fields generated by a scanner like this one would have violently ripped the magnetic shrapnel straight out of his body, destroying his vital organs in the process. Until medical science advanced, Stark's chest cavity remained an inescapable hostage to the mechanical limitations of his own life support system. Beyond simple biological containment, that system faces a massive energy requirement. The miniature reactor has to simultaneously maintain that thoracic suspension field and power a heavy, flight-capable exoskeleton. Looking at this chart comparing early reactor variants, like the Mark I, Mark V, and Whiplash designs, we see significant design trade-offs. There is a direct inverse relationship between maximum energy output and structural integrity. Pushing these early miniature designs to their limits exposed a fatal physical flaw in relying on a palladium core. When subjected to high energy output, the palladium degrades rapidly, releasing lethal heavy metal toxins directly into the bloodstream. To manage this rapid decay, while achieving highly compact transportability, Stark was forced to severely scale down the energy output, a compromise visible in the reduced capacity of the Mark V briefcase armor. Stark's engineering created a grim biological paradox. The exact engine required to keep his heart beating was poisoning him to death on a cellular level. Stark eventually solved the palladium decay by decoding an atomic map hidden within the architectural layout of the 1974 Stark Expo. He synthesized a highly stable new element, famously attempting to patent it with the government under the name potassium. The blueprint for this element originated from his father, Howard Stark. Following World War II, Howard recovered the tesseract from the ocean floor and studied its limitless energy signature, though he lacked the technology to replicate it at the time. By constructing a miniature particle accelerator in his workshop, Stark successfully fused atoms together, constructing a stable, non-cosmic recreation of the tesseract's energy matrix. This cosmic synthesis pays off directly during the events of the Avengers, when Loki attempts to initiate a neural override using the Mind Stone housed inside his scepter. The scepter fails with a simple metallic clink, but the underlying cause is pure energetic physics. Because the arc reactor is powered by an element modeled on the tesseract, It emits a localized field of space stone-derived energy. The contact between these two conflicting infinity stone frequencies completely neutralizes the psychic transmission. By mastering this specific atomic structure, Stark turned his cardiovascular life support monitor into an impenetrable infinity stone shield. The physical limitations of mechanical thoracic containment eventually forced Stark to abandon the hardware approach entirely. Instead, he turned to the Extremis program, an advanced biological nanotechnology. During his surgery, Stark received a highly controlled, non-volatile dose of a modified Extremis virus. The nanites interfaced directly with his neural repair centers to instantly regenerate his damaged heart tissue, his muscular wall, and the excised rib structures. Across the trilogy, the Arc Reactor transitioned from a survivalist stopgap to a sophisticated bridge between medical science and atomic synthesis. Tony Stark built the Iron Man armor to fight global threats, but to survive his own creation, he had to reverse engineer the energy signatures of the universe just to keep his heart beating.